Hi everyone, my name is Marcus and you're watching the Reef Nerd YouTube channel. Today's video is a little bit different. I'm going to be putting forward a guide on how to set up a Raspberry Pi based Reef Cam webcam setup. You can monitor from any device that has an internet connection from anywhere in the world. Now, a word of warning, this video is going to be very, very long. I think it's about 55 minutes long. So if you're not actually looking to do this, you might find the video a little bit boring because it's a very granular tutorial. The reason why I've made it so granular is so that anyone can follow the steps. You don't need to understand what you're doing, you just need to be able to follow my instructions and you should be able to go from nothing to having a fully functioning Reef Cam in about half a day or a couple of hours. I would think it would take most people to do this with limited experience. Down below in the video description, I'm going to have some notes and some helpful tips, as well as a link to download the full written PDF version of this guide, which might help some people get through it all, given that the video is so long. If you have any questions or you get stuck, post a comment down below or message me on Facebook. All right, let's get into it. All right, so part one of setting up a Raspberry Pi Reef Cam. We're going to go through the hardware that you need. Obviously, you're going to need a Raspberry Pi. I recommend the Raspberry Pi Model 3 B+, which is the latest and greatest model. It's also the most powerful. The more powerful your Raspberry Pi, the higher the resolution and overall better quality of the video that you're going to be able to capture in your Reef Cam. However, older model Raspberry Pis will get the job done. But preferably I would go with a more powerful one, so go as high as your budget will allow. As you can see, this one from Core Electronics is $55. Next, you're going to need a power supply for it. Any micro USB power supply will do, or for that matter, an iPad charger or something like that. You probably want something more beefy than a standard phone charger that's 5 volt 1 amp. Preferably you want something that's rated a little bit higher. The recommended one from Raspberry Pi is rated at 5 volt 2.5 amp. You're going to need a micro USB card. Nothing crazy, you don't need one that's super big. The operating system and the files aren't very large, so 16 gig or larger will do. You can buy this one here that comes preloaded with a tool called Noobs, which essentially is an auto installer for a lot of the operating systems. That's not essential because I'm going to walk you through how to install the operating system later on in the guide. You're going to need a camera. Now, there are quite a few different Raspberry Pi cameras available on the market. This is the one that I use and that I've tested, and its quality is exceptionally good. Its aperture and settings seem to work really well with reef tank lighting. I'm not sure how much of that is the software and the drivers in the Raspberry Pi operating system and how much of it is the camera itself. As I said, I've only tested this camera, but if you want to take a gamble on a cheaper one that's available on eBay, go for it. But I do know that the official one here that's a little bit more expensive gives exceptional video quality, and that's the one that I'll be using. The cable that comes with the camera is only about 10 centimeters long, so I recommend buying a longer one. I bought this one at $7.50 for and it's a meter long. That allows you to separate the camera from the Raspberry Pi. So think about your mounting, think about where you're going to put the Raspberry Pi, where you want the camera to be. You might need a longer cable. The next thing is optional but highly recommended, and that's a case of some description. Preferably get one that looks remotely waterproof, given the application. We're building a reef tank camera, and as you know, with our reef tanks, there's a high possibility of salt water getting on anything in the vicinity. This is the case that I happen to use just because I thought the colors were cool and it looks pretty snazzy. But you can there's a myriad of Raspberry Pi cases on the market, and there's certainly ones that are more waterproof than this one. In fact, there are ones on the market that are actually IP67 rated if you really want to go that far. But a case is definitely a good investment. You also might want a mount for the camera. This is the one that I got. It's got some standard mounts and holes on it for all kinds of camera equipment and the type of mounting options you might want. So look into something like this if you're going to be mounting the camera somewhere near your tank. And then finally, this is only relevant if you bought the Raspberry Pi 3 B+, that's the latest and greatest model. You can forego the power supply and instead buy this PoE hat. This will allow you to power the Raspberry Pi over Ethernet. This is only relevant if you, 1, have run Ethernet to where the Raspberry Pi is going to be, and 2, have a PoE switch, that's power over Ethernet switch that can supply power to the Raspberry Pi, or you want to use a PoE injector elsewhere in your house. If you have no idea what I'm talking about, don't worry about it, this is probably not for you, but I just wanted to highlight for those who do know what PoE is and are going to use the latest model Raspberry Pi. It's available and it's actually how I run mine, and it can help keep your cable cluttered down, and it's just a cool toy to have as well. Alright, so that's all of the hardware. Obviously the primary things that you need, the absolute essentials, is the Raspberry Pi, a power supply, a micro SD card, and the camera. And more than likely, depending on how you're going to mount it all together, you're going to need a longer cable, and I would definitely say that you should get a case for the Raspberry Pi at a minimum too. So that's the end of part 1 and all of the hardware that's required to set up this Raspberry Pi Reef Cam. For this guide, we're going to be using the latest version of Raspberry Stretch Lite as the operating system for the Pi. The Lite version does not include a graphical user interface. We're choosing this as it would just waste system resources and it's not needed for our use case. However, if you think you'll want the graphical user interface that is like the operating system desktop view of the Raspberry Pi, feel free to install the full version of Stretch. It won't change any of the instructions except which of these 3 you select. Now obviously I'm going to be using Stretch Lite, so I would click it, download the zip file. While that's downloading, you want to go to balena.io and download Etcher. Etcher is available for Windows, Mac and Linux, so it won't matter what operating system you're doing this on. Download a copy of Etcher. Once that's finished downloading, it won't take long, it's not a big file. Simply install it and open it, and it should look like this. At this point, you want to plug your SD card into your computer. Mine's already plugged in, so it's appeared here. So you can see it's a SanDisk SD card, and it's a 64 gig SD card. Make sure that it's the right device that is selected here, because what we're about to do is image the device, which means essentially wiping it and installing the new operating system on it. So you don't want to be selecting your hard drive or anything like that. So once Raspbian Stretch has finished downloading, you want to select the image. It'll be in your downloads folder. Where is it? There it is for me, the latest version of Raspbian Stretch that we just downloaded. You want to click open, and then you want to click flash. This will take a couple of minutes, so go make yourself a coffee, and once it's finished, come back and continue watching this video. Okay, so this is what it looks like once Etcher has finished flashing your SD card. At this point, all you want to do is close Etcher, unplug your SD card, plug it back in, and you'll see that a drive called boot is now available in my computer. If you're on Windows, like I am right now, you'll just open this, right click, go to New, create a text document, and you just want to call it SSH, and then you want to delete the .txt file extension on the end. Windows will say, are you sure you want to change the file extension? Say yes. So you've essentially created a blank file with no file extension called SSH. If the file extensions don't appear for you like they do for me here, you want to go into View and tick this box here called File Name Extensions to make sure that they're visible. If you're on a Mac, it's a little bit different. It's actually a little more involved to create a blank file like that. There's a few ways to do it, but I wrote these instructions here. They seem to be the simplest. you just want to open terminal, type cd space / users with a capital U, type ls and press enter. Now then you're going to see a list of your user account folders. It should be pretty obvious which one of them is yours, the one that you're currently logged in as. It'll probably be your name. So then you want to type touch space / the case sensitive exact spelling of your username folder / desktop with a capital D / SSH and press enter. That will create that blank SSH file on your desktop, and then you can simply drag that into the boot drive, which is the boot folder of the SSD that we just created with Etcher. The reason why we're adding this file is to enable SSH in our Raspberry Pi operating system straight off the bat, which is how we're going to be accessing it. Given that it's headless, that eliminates the need for us to be putting a keyboard, a mouse, or anything like that into the Raspberry Pi. We can simply give it power, attach it to our network, and away we go. Eject the SSD from your computer. This is how you do it on Windows. It's largely the same on the Mac. There we go. And you then want to go and take the SSD, put it into your Raspberry Pi. You want to connect the camera module to your Raspberry Pi if you haven't already done so. And you'll want to pay close attention to the orientation of the ribbon cable as you're doing so. The gold tabs on the cable need to be facing the side of the connector with the pins. Plug your Raspberry Pi into power and plug it into Ethernet. You may need to temporarily set it up in a location near where your router or your modem is in order to do this if you don't have Ethernet all around your house. Don't worry, if you plan on using it on Wi-Fi, that's pretty easy to set up once we're connected to the Raspberry Pi. But for now, let's just get it running on Ethernet. If you know how to get the IP address of your Raspberry Pi from your network or from your router or some other method, please do so now once you've got it connected and powered on. If you do not, you may need to plug in a monitor and a keyboard into your Raspberry Pi. You'll see a terminal window appears on your monitor, and you'll have to type hostname space dash capital I and press enter. It will then give you the IP address of your Raspberry Pi. I'll link an article down below if you're having difficulty, which is a bit of a guide on exactly how to get the IP address of your Raspberry Pi. But you will need it moving forward, so make sure you jot it down. From here on out, we'll be doing everything over SSH, sending commands remotely to the Raspberry Pi from our main computer, desktop, or laptop. On a Mac, you can simply use Terminal to do this, which is part of the operating system. On Windows, you'll need to download and install PuTTY, which you can just go to Google. It's just putty.org. And you're going to type in Pi as the username, and the password is Raspberry, just like that. On the Mac, what you would have done is you would have just opened Terminal, and you would have typed SSH space Pi app, and then you'd go 192.168.1.7 or whatever the IP address of yours is, and you'd press enter, and then you'd type in Raspberry. So that's how to SSH into your Raspberry Pi. If you're having trouble getting the IP address or SSHing into your Raspberry Pi, go back, rewatch the right sections, or read down in the description below the detailed instructions. Okay, so now what we're going to do is SSH into our Raspberry Pi, and we're going to use the tool here, the terminal here, to enter some commands to get our Raspberry Pi ready to run all the software that we need. The first thing that you're going to want to do is type the following command: sudo rpi-update. Now, what this is going to do is update the firmware on the Raspberry Pi. It'll probably take a couple of minutes, but it's an important step to do because this makes sure you have the latest firmware that's capable of running the latest drivers for our camera. This message comes up asking if you'd like to proceed. Just press Y. Once that update's finished, your Raspberry Pi will probably need to reboot, and you'll probably also need to SSH back into it. So go ahead and do that, and then once you're in, I want you to type sudo raspi-config. And that will bring up a menu that looks like this. From here, you want to use your arrow keys on your keyboard to go down to interface options, which is the 5th option here for me. Press enter, and you'll see that the first option there is camera. Just press enter on that, and it will say, would you like the camera interface to be enabled? Yes or no. Go across and select yes, and then press enter. So the camera interface is enabled. While you're in here, there's a couple of other things you could look at. You can go in and set up Wi-Fi in your network options here. So if that's relevant for you, go and do so. You'll enter your SSID, that's your Wi-Fi name, and your password. The other thing you can do while you're in here is go in and change usernames and passwords for the current user. So if you no longer want to use the username Pi and the password Raspberry, you can change that. And you can set localization options as well, such as your time zone. The Wi-Fi country you'll probably need to set as well to Australia if you're going to use that. Once you're finished, go all the way to the bottom, select finish and press enter. It will ask you if you want to reboot, and say yes, and your SSH connection will close. Give the Raspberry Pi a couple of minutes to reboot and SSH back into it. So SSH back into your Pi, and once you're in, you're going to need to type in a fairly long command, so I suggest copy and pasting it from the description down below. This is the command here. Press enter. Then you want to type cd sudo nano etc apt sources.list, and into this file you want to paste the following line. There we go, just make sure it's exactly like that. Then you want to press Control-O and then hit enter, and Control-X, that's to save and exit the file that we just edited. So what we've just done is add the source that we're going to be using to download some of the software we'll be using. UV4l is the primary tool that we'll be using to run our Raspberry Pi camera. The next commands we want to type are sudo apt-get update, and then you'll hit enter. Once that's finished, you'll want to install sudo apt-get install UV4l UV4l-raspicam, and then once that's finished, you want to type the same thing except UV4l dash Raspberry Cam dash extras space UV4l dash server space UV4l dash mjpeg stream UV4l dash demos, and finally UV4l dash xmpp dash bridge. So again, all of these commands you can copy from down below, and then once all of this is finished installing, you'll want to install UV4l dash WebRTC. Now, if you're running a Raspberry Pi 1 or 0, which is probably not recommended given its weaker hardware, this instruction is slightly different. Instead of installing WebRTC, you'll be installing WebRTC-ARM v6 because it has those Raspberry Pis have a different processor. Okay, so once all those things are installed, and some of them will take longer than others, it took my Raspberry Pi about 10 minutes to install all of that. It'll also depend on your download speed with your internet. There's one more command that you need to run for now, and that's the one I have on the screen here, sudo service uv4l underscore raspberrycam restart. Run that, and hopefully there's no errors and it just occurs, and then the next line comes up. Note down that command, probably write it on a piece of paper or something, because we're going to need it a fair bit moving forward, and it's also going to be your go-to command if something's not right with your camera. So anytime it's not working or it throws an error or anything like that, this is the first thing you should be doing, is running this command. It restarts the whole service that runs the camera and the software that we're going to be using. Alright, so now we are ready to test the UV4l service and make sure that it's working and make sure that our camera is working and that we did everything correct. So that's really easy to do. We're just going to open up Chrome, is what I'm using here. You can use any web browser, but if it doesn't work, try with Chrome like I'm using. I've found browser compatibility to be a little bit all over the place. So if one doesn't work, try another, is my advice. You want to go to http://, then type in the IP address of your Raspberry Pi. For me, that's 192.168.1.7. Then you want to go :8080. Hit enter. And if something like this loads, big cheer. That means the UV4l service is running on your Raspberry Pi. Now we can test the camera. The best way to do that initially is to just click this this second icon here, the one that says JPEG on it, or MJPEG stills stream. So click on that, and an image like this should load. Don't be alarmed that it's might be really slow to load, and don't be alarmed if it's really stuttery like this one, for example, is. This is not the video stream. This is actually just a series of still images, and they can be quite high resolution with the default settings as well. So this is just purely to test that the camera works. If it's upside down or anything like that, don't worry about that for now. We'll fix that later. And the next thing I want you to do is go back and then click on this first icon here that says two-way audio video. And in here, if you scroll down, you'll see at the very bottom there's a call button. So I want you to press that. Scroll back up to the top, and you should see video stream now start. And this should be much smoother video. Not completely smooth, but it should be much smoother. If that loads correctly, that's great. Scroll back to the bottom and click hang up. You always have to hang up with this particular tool that we're using right now. And then I want you to tick this little box here that says force the use of hardware codec. Just tick that scroll to the bottom and click call again. And what you should see is a much smoother, higher resolution video. It'll also be bigger, as you can see here. So if it's not smooth, if it's stuttery, what you then want to do is hang up, and then from this drop down next to that video force use of hardware codec box that we just ticked, select another resolution. By default, this one is the one that's selected, so if your video was stuttery, lower the resolution and choose one of these lower ones. If your video was perfectly smooth, feel free to bump it up and go higher and try one of these higher resolution ones. Test the limits of your network and your Raspberry Pi, and also just the resolution that you're comfortable with. Find the one that works for you. That will be different for everybody. For now, I'm just going to assume that this first one here is the one that worked for you, and that's what we'll continue with. But feel free to select whichever, also feel free to find out which one works for you and then note it down. Any settings you change on this page that we're on right now are only temporary, so we're just using this page to find the setting that works for us. If the video failed to load after you ticked the force use of hardware codec, try a different web browser. For me, on a Mac, I've found that this force use of hardware codec doesn't work on Firefox, but on my Windows PC it does work on Firefox. For me, it works on Chrome no matter what computer I'm using. I've not tested Internet Explorer, and I've had some luck with Safari as well. So just test different web browsers until you find the one that works for you. Hopefully it'll just work straight away. But ultimately, my recommendation is to find a web browser that works with the use of the hardware codec, because you get much better image quality. Once you've finished playing around and you've jotted down the resolution that you want to be permanently set for the camera and for the website that we're going to set up next, we can move on. So now that we know our camera is working, we've jotted down the resolution settings that we want to use, and we've tested which web browsers it does and doesn't work on for your specific computers and with the hardware acceleration. We can permanently edit the configuration settings of the camera. So open back up an SSH session with your Raspberry Pi. If you've still got the other one open, you can continue with that, or if you close that, just open a new one. And what we're going to do is type the following. Type cd, then type sudo nano, then /etc/uv4l /uv4l hyphen raspi cam.conf. And you'll see I made a spelling mistake there. I'll just correct that. There we go. So type this command here, hit enter, and it should load that file in your window like this. And this is a very large file. There's a lot of configuration options in here. Don't be intimidated by it. Just start scrolling down it. I'm using the down arrow, and you'll note that a lot of the settings have an asterisk in front of them. That means they're commented out and they're not currently applied. That's fine. Most of them we're going to ignore. As we're scrolling down, the first one that we're going to look for is just here. So under this section called Image Settings Options, there's H flip and V flip. If you were to uncomment those, like so, and change the no to a yes, you can probably guess what this is doing, but one of them vertically flips the image and the other horizontally flips the image. So if you'd set up your camera before exactly how you want it, but found that the image was upside down or 90 degrees offset in the wrong direction, you can edit these two settings here in order to correct that. Now mine was fine, so I'm just going to comment them again, but they're the two settings to change the orientation of the image. Now I want you to scroll quite a bit further down, and what we're looking for is a section with the title WebRTC options until you find it here. Now you want to uncomment this one, this one, this one, this one, this one, and this one, and you want to set the audio to no. That is, unless of course you want audio from your camera. You also want to scroll down a little bit further and look for the one here where it's max playout delay equals 34, and make sure that that is uncommented, as in it doesn't have an asterisk in front of it, which it shouldn't. Now then you want to find another section right near the bottom where it says these options are specific to the HTTPS server. And you want to uncomment this first one and change it to yes. Uncomment this second one and change the path from ending in www/ to ending in demos/ReefCam. Then you want to uncomment the next two lines like so, and scrolling down a bit you want to uncomment where it says max queued connections equals 8, the one beneath that max threads equals 4, and the one beneath that thread idle time equals 10. Finally, second from the bottom just here, you want to uncomment this line with the www WebRTC signal path equaling /WebRTC. There are many other options in this file that you can edit. I'm not going to go through all of them, but there is the capability to be able to add a username and password for the access. There's the capability to set up security certificates and all kinds of configuration options for the camera itself. For now though, this is all we're going to do. So just go Control O and hit enter, and then Control X. That's save and exiting that file. Okay, so type CD and hit enter. Then type CD /user or USR /share /UV4l /demos. Then you want to type sudo mkdir space ReefCam. Then type cd ReefCam. Now type sudo wget and then this URL, which you can copy from the instructions down below. The full URL's on the screen. It's https://github.com/raspberry-pi-reefcam-demo-site/archive/master.zip. And what you'll see is it downloads a file from my GitHub. Once that's finished downloading, you want to type sudo unzip -j master.zip, and you'll see it's unzipped or inflated 4 files: adapter.js, index.html, main.js, and signaling.js. This is the basis for our website.
Now you're going to want to restart the UV4l Raspberry Cam service with this command: sudo service UV4l Raspberry Cam restart. And from here, we're going to now test the website. So open up Chrome and come to this address, the IP address of your Raspberry Pi. In my case, it's 192.168.1.7, and then :8888, and you should see this website load. Hit the start streaming button, and if you're in luck, your fish tank will appear. If nothing happens, press stop, untick the codec, and press start streaming again. You'll note, in my case, the quality is much lower with the codec turned off. This is almost always the case. So if your web browser supports the hardware codec, I encourage you to always leave it turned on. For me, it works in Chrome and doesn't work in Firefox. Your results might vary. Now, for me, with these default settings, it's a really high quality picture and quite a good frame rate. You can see there's not too much stuttering. I can clearly see the fish swimming. I'm pretty happy with this. However, your results might vary dependent on the testing we did earlier. As you saw, your network speed, the hardware that you're using, so what generation of Raspberry Pi you're using, and other factors will influence how good the picture you're getting right now. So what I'm about to show you is how to come in and edit and tweak the settings to best suit your specific scenario. And always remember to press the stop stream button every time you've clicked the start stream button, especially if the video failed to load, because you've probably still sent the command to the Raspberry Pi and it's taking up a thread in the background even if your web browser isn't showing the video thread, so you always need to tell it to stop. So bring back up terminal or your SSH session and just check that it looks like this, as in you're still in the same path that I am in the ReefCam folder. If you've closed the session or you need to do it again to get back there, just type cd and then type cd/share/uv4l/demos/reefcam. Now from here you want to type sudo nano index.html. Now this is the primary file that makes up our website. In here you can edit various things. If you don't have any knowledge of HTML or CSS, I suggest all you do is change the title just here where it says Fishcam to whatever you want it to be. Then scroll down further and look for this H1 block where it says Reef Nerd Fishcam, and you can edit that to call the website whatever you want it to be as well. At that point, you should just press Control X and Control O, then Control X in order to save and exit. If you know what you're doing and you want to change the colors and things like that, feel free to go for it, but it's a little bit outside the scope of this tutorial. So right now, I'm not going to make any changes. I'm just going to go Control O, Enter, and Control X. Now you want to type sudo nano signaling.js. Now this file looks kind of scary, but we're going to ignore most of it. Just scroll down, as you can see I'm doing, and what you want to look for is probably, I think, about 3/4 of the way down, this section here. And I've got already in here all these comments for the code that you're going to need. So looking here, the value of 10 is used to change the video to a resolution of 320 by 240 at 30 FPS. The value of 60 is used to change the resolution to 1280 by 720 at 30 FPS. And you get the idea for all these other values in here. You can play around with this to figure out which of these is the best for you. The default value that I have in here right now is 60, and you can see that set here where it says vformat:60. So all you would need to do, say if you wanted to test the performance of the camera at 1920 by 1080 30 FPS, is change that 60 to 105. Or if you were getting really poor performance on the default when we tested the website just before, maybe try changing it to 30, which will halve the resolution, and running it at 640 by 480 30 FPS. If that runs really well, maybe bump it up a bit and try 40. So you can keep coming back in here and changing the value next to this vFormat parameter. And that's really the only thing we need to edit in here to dictate the quality that the camera streams in. And this will be a unique value for you. I've found that 60 works well for me, but you can play around with it and see what's going to work best for you. Once you've finished and settled on a value that you want to try, what you need to do is press Control O, Enter, and Control X to save and exit. And then you want to restart the UV4l RaspiCam service with this command, sudo service UV4l_RaspiCam restart. Every time you make a change to one of these files, it's best to restart the service. So now we have a fit-for-purpose website that we can use to see our camera. However, it's currently only accessible locally, i.e. on our home network. To make it accessible externally, say from our phone or on public roaming internet anywhere in the world, there are a few options. A couple of them are out of scope for this guide, such as setting up a VPN to be able to browse your local network externally as if you were at home. There's plenty of guides online on how to do this, and there's many ways to achieve it. The other way is to buy your own domain, set up a web server, and have that push the Raspberry Pi hosted web page through a reverse proxy to your self-hosted and secure site. And this is what I've personally done as I run a home server. That's a little bit more involved and complicated, so for now I'm going to do something just a little bit simpler and show you how to get it up and running a lot quicker. What we're going to do is set up a dynamic DNS listing through a free domain provider and have that point directly to our Raspberry Pi with port forwarding on our router. I know that sounds complicated, but it's really not that hard, and I'll walk you through it. So to begin, open a new tab and Google and just type, "What's my IP?" And you'll get something like this. This is my public IP address today. It changes all the time. Yours will look similar to this, and every week or a couple of days or whenever the direction of the wind changes, your IP address will probably change. So just jot this down or keep this tab open. In another tab, I want you to go to duckdns.org and pick one of these options at the top to log in. You have to log in with one of them. So if you've got a Twitter account, a GitHub, Reddit, Google account, one of them, pick one and log in with one of these. For me, I'm going to sign in with my Google account. Once you're in, you can create a free subdomain, which will be something, and you type in whatever you want where I'm typing right now, and then click add domain. Once you've found something, it has to be unique, so if your first choice is already taken, try again. You'll have a listing like this down here, and I want you to enter your current IP address in this field that says current IP and press the update IP button. You've just manually told DuckDNS what your IP is, and that new subdomain which you've just created will soon be pointing at that IP. However, because your IP is always changing, we need to set up a way for DuckDNS to always know what your IP address is so that it can automatically update it for you. To do that, at the top, click Install. And then from this massive list here, choose Pi. It's in the list of operating systems. Then scroll down. You want to choose the domain that you just chose. And the instructions are laid out for you on this website. I don't need to repeat these for you because they're here. You just copy each of these commands into your Raspberry Pi in order. And once you get to the end, what you will have is a DuckDNS service running on your Raspberry Pi that's automatically going to update DuckDNS anytime your IP address changes. Now I want you to come to portforward.com and I want you to click on list of routers here. Scrolling down, you want to find the brand of your router. So for example, let's say you have a Netgear router. If in doubt, find your router and look at the label. You'd go to Netgear, if it was Netgear. Now you ignore this ad that comes up. We're not going to buy anything, just click close. So in this example that you have a Netgear router, if you have a D-Link router, you'd go to D-Link. If you had any other brand, you could find the right brand on this. Hopefully it's on this website. And find the model number of your router. And I'll just select the first one here, assuming... this will then give you instructions on how to set up port forwarding on your router. The reason why we have to set up port forwarding is we're hosting our website on port 8888, and we need to tell our router that when a request comes in from that DuckDNS domain that we set up before, that it has to go to port 8888 on the Raspberry Pi. So these instructions should help you to set up port forwarding on your router. How to log into it, where to find it in your router's guide, your router's wizard, and how to do the setting. It's different for every router. On my router, this is what it looks like. So often the default login for routers is admin for the username and admin for the password, or admin for the username and password for the password. But again, there might be a sticker on the router, or it might be slightly different for yours. You might have to do a bit of Googling. Hopefully that website I showed you will help you. But once you get in there and you're in the right area, it's sometimes called virtual server, sometimes it's called port forwarding. In my case, it's called port forwarding, and it looks like this. You give it a name, say Fishcam. Requests from anywhere on port 8888 will be forwarded, and that's where you would enter the IP address of your Raspberry Pi, and then the port you want to forward is 8888, the protocol of both, or if the option is TCP/UDP, you want to select both, and then press save. You may have to restart your router once you've done this. Now, in order to test that this works at this point, you want to go to your public IP address. That's the IP address we got by Googling what's my IP address, and then :8888, and that should bring up the Fishcam website. If it does, happy days. Now you can test your domain .duckdns.org :8888. Hopefully that works as well, and that would be your publicly accessible way of always getting to your Fishcam. If it doesn't work, don't stress. Domain propagation is likely the cause. What you want to do is go to dnschecker.org, and you want to type in your DuckDNS domain. So it'll be like your domain.duckdns.org, and click search, and what will likely be occurring if it's not working is you'll be getting red crosses where all these ticks are coming up. You may have to wait up to 48 hours for it to fully propagate. Domain propagation can be really painful, but hopefully it's quite quick. I've always found DuckDNS to be super quick. If you are getting all ticks here, then it should just work. If it's not working, you probably haven't set up the port forwarding correctly, or the IP address isn't updating correctly against your DuckDNS record. But that should be the end, bring us to the end of this tutorial at this point. You should have a fully functioning fish cam. The next step with this project would be for you to buy your own custom domain with a free DYN DNS service such as Namecheap.com. Set up a self-hosted web server such as an Nginx server and use a reverse proxy to the UV4l server. You could also use Let's Encrypt to generate a HTTPS signed certificate. At that point, your camera would be accessible on https yourdomain.com, which would be much more secure and a really cool project. That's what I run using the Linux server.io Docker container for Let's Encrypt, which includes Nginx within it. It goes beyond my ability to write a guide or tutorial for exactly how to set that up though, because there's just too many factors and variables in terms of everyone's hardware and the way that they will be able to set it up. But it's definitely doable for the moderately tech savvy person, and a really good learning experience. So I hope you found this guide useful. If you've run into any issues along the way, please post comments down below or contact me on Facebook, and I'd be more than happy to help you.